Hello, welcome to lesson 6-2. We're going to be talking about inverse functions and relations. We're going to be taking what we talked about in section 1, especially with composition of functions, and applying it here to make inverses of different functions or relations, depending on the set of information that you have. And we've already in the past taken an equation and, as they say, transformed it and solved it for a specific variable. That's essentially what we're going to do as we try to determine what a function's inverse is. So we'll apply that to find an inverse function or relation, and we're also going to look at whether two functions or relations are inverses of one another. Now, you might be saying, well, why would we want to figure this kind of stuff out? How is it practical? Well, for example, this is just one brief example. Let's say, for example, the amount of pesos is equal to 10.75 times the amount of dollars that you have. So 10.75 times D, let's say for dollars, equals however many pesos you would have. Well, that's a function. Now, if we had its inverse, we would be able to say that the amount of dollars we have equals, in this case, it'll be 0.09 times P for pesos, and it will tell us if we know the pesos, multiplied by 0.09, we'll have exactly how many dollars we would have. Those are inverse functions of each other. It allows us to, inverse functions allow us to find out information kind of one direction, and then if you have basically the function value, you can use the inverse to go back and find the independent variable. So it allows us to work in both directions. Now, as we work today, it's going to be important to remember opposite operations and how they pair up, because we're going to use that as we solve. So things like addition and subtraction, multiplication and division, roots and powers, square root and squaring go together, cube rooting and cubing go together, 11th rooting and the 11th, taking something to the 11th power go together. You never know what kind of problems might show up in the homework. So keep those things in mind. Also remember your order of operations. When you have to solve things, you're going to need to remember things like you deal with things in grouping symbols first. Then you deal with exponents or roots. Then you deal with multiplication and division, and you work those across the problem left to right and top to bottom. Doesn't matter if division comes before multiplication, if you're working left to right and top to bottom. And then finally addition and subtraction the same way, left to right, top to bottom. So all that being said, tuck that away in your brain because you're going to want to recall it later. All right, so what are inverse relations? In words, there are two relations are inverses if and only if whenever one relation contains the element AB, so the ordered pair AB, and the other relation contains the element BA, or the ordered pair BA. So if you look at the two relations here, A has ordered pairs of 1, 5, 2, 6, and 3, 7. B has 5, 1, 6, 2, 7, 3. Notice each ordered pair in A has that order, same numbers written in the opposite order. These two are inverses of each other. If we're graphing it, all that's happening in an inverse relation is the X and the Y flip-flop spots. So things, in other words, are being reflected across the line Y equals X. Now we'll look at that a little bit more with graphs as we get going. Now I do want to point out also, sometimes when you see ordered pairs, it can be easier to write them in a chart, or you may want to write them in a chart. You're going to see them in a chart in your homework, by the way. You'll have your X column and you'll have your Y column or your F of X column, and just know that they're inverses of each other if one table has, if both tables have the same set of numbers, they're just in opposite order from first to second. And you could write them out as ordered pairs if you wanted to, and then see, do they pair up and just flip-flop order? All right, so one example here. And as we do the examples, if you want to pause, see if you can figure it out, and then pick up again with the video, you can most definitely do that. So let's say you had these ordered pairs, 1, 3, 6, 3, 6, 0, and 1, 0. They're the coordinates of the vertices of a rectangle. So what would be the inverse of this relation? And then we'll describe the graph. We'll look at what that means here in a little bit. In your homework itself, you're not going to do any graphing. But we can look at the visual of it to help you understand what's going on. So the inverse of the relation, then, means we need to flip-flop the order of all the ordered pairs. So 1, 3 becomes, you can see here, 3, 1. 6, 3 becomes 3, 6. 6, 0 becomes 0, 6. And 1, 0 becomes 0, 1. So that's the inverse relation. So when you have ordered pairs or a table or something like that, it's hopefully you think a real easy switch. All you do is just reverse the order. Now, graphically, plot the points. So if you plot the points, you had 1, 3. Okay, so it's going to be the green one first. Then you had 6, 3. Then 6, 0. And 1, 0. So flip-flop the order of the ordered pairs. Now all of a sudden you've got 3, 1. So you go 3 over, 1 up. You've got, what do we have? 3, 6. Then you've got 0, 6 and 0, 1. And it's reflected over what we say over the y equals x line. And all that's saying is your x and y values flip-flop spots in the ordered pair. All right, moving along. Next example. Which relation listed below is the inverse for the vertices of this pentagon? -3, 4, -1, 5, 2, 3, 1, 1, and -2, 1. That's right, it is D. Notice how all the x and y values just flipped-flopped spots. All right, let's keep moving. Now we're going to say, let's talk about a property of inverses. What it's saying is if a function and its inverse, and that negative f of -1, that's how we write inverse. We say they're inverses if you plug in a value into the original function, and it produces an answer, and then you put that answer into the inverse function, and it produces the original number that you plugged in. For example, you got x minus 4 and x plus 4. So we're saying f of x is x minus 4, its inverse is x plus 4. If I plug in 6 to the original, 6 minus 4 is 2. Now if I plug 2 in to the inverse, whoops, if I plug in 2 to the inverse, sorry about that, 2 plus 4, if I get 6, then these two are inverses of each other. Now, we're going to look at ways just to ensure that we know for sure that something is an inverse, rather than just plugging in a random number, because, I mean, you could just get lucky that it happens to be two lines that intersect or some, you just get lucky. However, we'll have ways that we can solve it, but this is really what it's saying. Now, find and graph an inverse. Like I said, we're going to focus more on the find part and less of the graph. So you're going to find the graph of find the inverse of f of x equals -half x plus 1. Let's focus on that. This is a 4-step process. Follow this process in order. Don't deviate from it. Okay, so the first thing you're going to do is you're going to take the function. You're going to take f of x out and you're going to drop y in it. So you're going to now have y equals -half x plus 1. That's the first step. Step 2, switch x and y. Just switch it. It sounds weird, but just do it. So now we have x equals -half y plus 1. Now step 3, we solve for y. So we're going to use opposite operations to solve. We're going to, you can decide how you want to do it. You can say, I want to get rid of the fraction by multiplying everything by 2. Or -2 in this case. So you have -2x equals y minus 2. Add 2 to both sides, and you have y equals -2x plus 2. Now, you could also say, I want to add 1 or subtract 1 from both sides and multiply them by negative 2. I would distribute then. Either way, you're going to end up with the same answer. And the last step, now you go back and you take y out and you put f to the negative first x. So f inverse of x. And so we say f inverse of x equals negative x plus 2. That process. F of x becomes y, swap x and y, solve for y comes out, f inverse of x goes in, and voila, you're done. Now, a lot of what we're going to do today, they're not going to be overly complicated problems. They'll be just a couple of steps once you get the process down and not get bogged down in the math of it all. All right. Now, let's just look at a graph just to see what's happening. Okay, so if we wanted to look at the graph, this is what we would see. This is the dotted line's y equals x, and you see the original is the blue this time, negative half x plus 1. It crosses at 1, or at 0, 1. Now, look at where the green is crossing. It's crossing the x-axis at 0, 1. So 0, 1 becomes 1, 0. And that happens for every other point. We could pick another point. Negative 2, 2 now becomes 2, negative 2. The x and the y's are flip-flopping spots. All right, let's see here. Let's have you try one more example. Now you need to find this inverse. So you're going to have to you're going to have to solve again. Remember, you're going to take out f of x, make it y, so you have y equals 1/3 x plus 6. Then you're going to flip-flop, and you'll have x equals 1/3 y plus 6. And then decide how you want to solve. A lot of times the book shows you getting rid of the fraction first. So multiply everything by 3. 3y equals x plus 18. Now, subtract 18 from both sides. You have 3x minus 18 equals y. And now you pull out the y, put in the f inverse, and you should end up with C as your answer. And this would be a graph. Like I said, I'm not going to worry too much about the graphing right now because we're not going to see it in the homework. All right, last thing. Two functions are inverses if you compose them both directions, f of g of x and g of f of x, and both times they equal x. So you got two functions. The question is, are they inverses of each other? Well, let's find out. So first, you're going to see if you compose them. So you put g of x into f of x, if it equals x. So we're going to say 3/4 of 4/3 x plus 8 minus 6. Distribute the 3/4. X plus 6 minus 6. Yep, that equals x. Now we go the other direction. You're going to take the f function and plug it into g. 4/3, distribute it. Should have x minus 8 plus 8. That also equals x. If they both equal x, they are inverses of each other. If you do the first composition, f of g of x, and you do not get x as an answer, you can stop. You can say they are not inverses of each other. All right, let's do one more example. After we say the functions are both inverses of each other. Okay, now let's do one more example. You're going to plug those into each other. Give you guys yourselves a moment to solve. And you will find out, hopefully you paused and you solved and you plugged x minus 1 over 3 into 3x plus 1. When you do that, the 3's cancel and you're left with x minus 1 plus 1. That's x. Then you go the other direction. You plug f of x in for g of x. So you have 3x plus 1 minus 1. So the 1's cancel out. 3x over 3 is x. So they are inverses of each other because they both equal x. This is the kind of stuff you'll be practicing today in your homework. Happy practicing.